All right, so this is your note for 3-5, systems with 3 variables. That's right, z is in the house. We're adding z to x and y, making it 3. We are going to solve systems in 3 variables using elimination and solve systems in 3 variables using substitution. Do not write this on your paper, just listen. Solve systems of 3 equations in 3 variables. You can use some of the same algebraic methods that we use to solve 2 systems of 2 equations in 2 variables. So we're going to use the same methods. It's just going to have one more dimension. So we're going from 2 dimensions to 3 dimensions. And you're writing none of this down. This is just information, listening, ears open, eyes open. After the learning objectives, you just will pause. So we can represent systems of equations in 3 variables. So now we're 3D. So we're not only going left and right, but we're coming out of the page right at your face. The graph of an equation of the form ax plus by plus cz equals d, where a, b, and c are not all 0, is a plane. So when you have 3 dimensions in an equation, it makes a 3-dimensional plane. So like the floor, or the ceiling, or the wall. That is a 3-dimensional equation. So if I had no solution, so if I have 3 equations and 3 unknowns, I'd have 3 planes. And if there is not one place where all 3 planes come together, then I have no solution. And it looks something like this. So I have orange plane, and I have beige plane, and I have sage plane, and they don't all come together in one point. Or 2 of my planes are parallel, and the other one goes through it. There's not a point where all 3 of them come together. Or all 3 of them happen to be parallel to each other. If I had one solution, that's where all 3 planes intersect at one point, and it happens to be right here. So these guys cross, and then this sage-colored plane crosses right at that intersection too. If I have an infinite number of solutions, it means that all 3 planes come together and form this line that goes on forever and ever. This is just information only, not needed to solve the stuff that we're going to do, but conceptually important. Now we're dealing in 3 dimensions, which is awesome, because if any of you guys have seen a CNC machine, if you have rims on your car, we use 3 dimensions to create and machine all the objects that run around in our lives. Okay, so now this is the writing part. We are going to solve a system of 3 dimensions using elimination. And the same rules for elimination apply as we had before. So we're going to solve x minus y plus z equals -1. X plus y plus 3z equals -3. And 2x minus y plus 2z equals 0. Give you guys a second to write that down. All right, so the first thing we're going to do is pair our equations so I can eliminate y. The reason I chose y is because I have a minus y in one equation and a plus y in another equation, and I know if I add the 2 together, the y is going to be eliminated. All right, so I'm going to go x minus y plus z equals -1. I'm just rewriting the top one. I'm going to rewrite the bottom one underneath it. Or sorry, the second one underneath it. X plus y plus 3z equals -3. Then I'm going to add these guys straight down. So x plus x gives me 2 x's. -y plus y gives me 0. 1z plus 3z gives me 4z's. -1 plus -3 gives me -4. So now I have 2 variables. I have x and z. I know how to solve systems using 2 variables. We did a whole chapter. So what I need, you always want to think of it like this. However many variables I have, I need to have that many equations. So if now I have 2 variables, I need 2 equations. So I need 1 more equation with x and z. So if I add the second and the third equations together, I will get another equation. The y's will cancel out, and I'll have an x and a z. 2 equations, 2 unknowns, solvable. So we go x plus y plus 3z equals -3, and 2x minus y plus 2z equals 0. I'm going to go ahead and add those together. X plus 2x is 3x. Y plus -y is 0. 3z plus 2z is 5z's. -3 plus 0 is -3. I have a crazy idea, and I won't do it if it's going to mess with your brain. Would you be okay if I took this equation 2x plus 4z equals -4 and I divided it all by 2? Are each of those coefficients divisible by 2? Yes. So I can get an exact one. So I'm going to go ahead and do that. I'm going to divide it by 2 because when I'm doing these advanced algebra skills, I want everything as simple as possible. So if I can recognize that, oh, everything's divisible by 2, so let's go ahead and make it simpler. Then let's make it simpler. Okay, so write the 2 new equations for the system as a system. Solve for x and z. So I got x plus 2z equals -2, and I got 3x plus 5z equals -3. I'm going to use elimination to solve this system because why not? So I'm going to multiply my top one by -3 because that'll give me a -3x. It'll combine with that positive 3x and it'll be eliminated. So I'm going to go ahead and multiply everything by -3. And I get -3x minus 6z equals 6. And I'm going to combine that with my 3x plus 5z equals -3. I'm going to go ahead and add those together. -3x plus 3x, 0. -6z plus 5z is -1z. 6 plus -3 is 3, and I get z equals -3. Okay. If z is equal to -3, let's go ahead and plug that in and find what x equals. I'm going to pick my simplest equation, x plus 2z equals -2, to plug it in. You could technically plug it into this one, or this one, I pick the simpler one. Work smarter, not harder. So we get x plus 2 times negative 3 equals negative 2. 2 times negative 3 is negative 6. I'm going to add 6 to both sides, and I get x equals 4. It won't spread. All right, so we're going to substitute negative 3 and x into one of our original equations to get what my y is. So I'm going to pick the first one because he looks pretty easy. He's got the least amount of numbers rolling around. So I'm going to go x minus y plus z equals negative 1. So I know x is 4. I do not know y. I know z is negative 3. And I know it equals negative 1. 4 plus negative 3 is 1. So negative y plus 1 equals negative 1. I'm going to subtract 1 from both sides. Negative y equals negative 2. If negative y equals negative 2, then regular y has got to equal 2. You can get that by dividing both sides by negative 1. So, I got them all. I got x, I got y, and I got z. We're going to write this solution as an ordered triple. An ordered triple means I got an x, comma, y, comma, z, comma, and they're inside parentheses. So I'm going to put my x value first, then my y value, and then my z value. All right, we're going to see this again. So let's look at the first, let's look at our functions. I'm looking at this bottom one. I'm in fact looking at these two. Because they have the same x term, they're both 2x, I can just multiply the bottom one by a negative and get that x to cancel out. So that's going to be my first step. So I'm going to rewrite my first one, and then I'm going to multiply this bottom one by negative 1. So I get negative 2x minus 2y plus z equals negative 4. Then we're going to add those two straight down to each other. 2x plus negative 2x is 0. That goes away. Negative y minus 2y is negative 3y. Negative 2z plus z is minus z. And 5 plus negative 4 is 1. So my first two variable equation is negative 3y minus z. So now I'm going to take these two, combine them together. I guess x or y doesn't terribly matter which one we eliminate. So I'm going to go ahead and multiply the top one by negative 2. Because I want to eliminate the x, because I've already eliminated the x here. What good would it do me to eliminate my y? I actually want the y, so I want something with a y and a z in it. All right, so E and S, the top one has a negative 2y and the bottom one has a positive 2y, and we could have just added those two together and eliminated the y's. Totally valid. We could have done that. Nothing wrong with that. So we're starting to get into multiple ways of solving the same equation. So I'm going to multiply my top by negative 2. We get negative 2x plus 4y minus 6z equals negative 24. Then I'm just going to rewrite this one. 2x minus y minus 2z equals 5. So if you find yourself not getting the right things, it's okay just to erase or start a new problem, new piece of paper. It's easy to get jumbled and mixed up, and sometimes redoing it on the same paper is confusing. So sometimes you just need a fresh sheet of paper and to start all over again. It's okay to try and fail as long as you try again. Negative 2x plus 2x, 0. 4y minus y is 3y. Negative 6z minus 2z is minus 8z. Yeah, we multiplied everything by negative 2. Good question. And negative 24 plus 5 is negative 19. So now I have two equations, both with y and with z. And if you look, smiling upon me. The sun is shining. The math gods are smiling upon me. Because I have a positive 3y and a negative 3y. So I can just add those two together and get it to eliminate the y's. Super simple. Okay. So I'm just going to rewrite my first two variable equation right underneath my second one. I'm going to add those guys straight up. 3y minus 3y, 0. Negative 8z minus 1 more z is negative 9z. Negative 19 plus 1 is negative 18. Oh, and when I divide by negative 9, I get z is equal to 2, and it's oh, happy day. So then I'm going to take this one, negative 3y minus, I'm going to put 2 in for z, equals 1. My 2's and my z's look the same, that's why I crossed my z's. So here I'm going to go negative 3y minus 2 equals 1, add 2 to both sides, negative 3y equals 3, divide by negative 3, y equals negative 1, another happy day. So I know z is 2, y is negative 1, I just need an x. So let's pick Mr. Top one right here. So x minus 2y plus 3z equals 12. We don't know x. We do know that y is negative 1. We do know z is 2. And we know when we do this math shenanigans to it, it equals 12. Almost done. Almost done. Negative 2 times negative 1, positive 2. 3 times 2 is 6. Equals 12. 2 plus 6 is 8. Minus 8 from both sides. X is equal to 4. Let's write it all as an ordered pair. Okay. So we write that all as an ordered pair. 4, comma, negative 1, comma, 2, close parenthesis. That is our answer. You only had a hard time doing that. Solving a system using substitution. So you can solve this using elimination. That's all right. No problem. But we're going to use it solving substitution. So I'm going to choose equation 1, and I'm going to solve for z. So we have x minus 2y plus z equals negative 4. So to get z by itself, I minus x, and I add 2y to both sides. So I get z equals negative x plus 2y minus 4. Step 2, substitute substitute z into the second and third equations. So my second equation is negative 4x plus y minus 2. And instead of putting z, I'm going to put in negative x plus 2y minus 4 equals 1. And then for my third equation, I'm going to put in, so it's 2x plus 2y minus parenthesis negative x plus 2y minus 4 equals 10. So now we're going to take those two equations and simplify them. Negative 4x plus y minus negative 2 times negative x is positive 2x. Negative 2 times 2y is negative 4y. Negative 2 times negative 4 is positive 8, and that equals 1. We are going to combine like terms. Negative 4x plus 2x is negative 2x. Y minus 4y is negative 3y. I'm going to subtract 8 from both sides. So I get equals negative 7. All right, next. I just moved the 8 over to the other side. 2x plus 2y. I'm going to distribute this negative to everything in this parentheses. Plus x minus 2y plus 4 equals 10. Then I'm going to combine like terms. 2x plus 1x is 3x. 2y minus 2y, no y's. I'm going to subtract 4 from both sides so that all my numbers are on the correct side. And there's a burnt halo. I actually get rid of my other variable. So I get negative 2x minus 3y equals negative 7. And I get x equals 2. And I solve for what? Let's do that. So negative 2 times 2 minus 3y equals negative 7. That's negative 4 minus 3y equals negative 7. Add 4 to both sides. Negative 3y equals negative 3. Divide both sides by negative 3. And y equals 1. X equals 2, y equals 1. Let's go ahead and find our z. I'll take the top one. Oh no, I'm going to take this guy. Z equals negative x plus 2y minus 4. Negative 2 plus 2 is 0. Minus 4 is negative 4. X is 2, y is 1, z is 0, and I can't find just can't find it. So let's write that as an ordered pair. 2, 1, negative 4. I was looking for my answer. All right, that's all for notes today. You guys can write your summary.